Hello, and welcome to Kotlin Native Snake. Dmitry, I've been programming Java for about more than 10 years, and I spent last couple of years working only with Kotlin. So this talk is basically from Java developers for Java developers, or from Kotlin developers for Kotlin developers even. But if you don't know Java or Kotlin, I think you should be just fine. And before doing actual live coding, I thought it might be useful to do a lightning talk explaining, for example, what is Kotlin Native, right? So what is Kotlin Native? Here is the closest you can get. That's the homepage pretty much at kotlinlang.org. And from this page, you can see Kotlin Native is a technology for compiling Kotlin code to native binaries which can run without a virtual machine. So that's the simple definition of Kotlin Native, right? Just as Kotlin, it's an open source project, Apache 2 license, that's its GitHub page. And like Kotlin itself, it's developed by JetBrains. And unlike Kotlin, Kotlin Native is still not released. It's in beta right now, so don't expect too much from it, right? And here is the definition, a bit more full definition from GitHub, which goes like, Kotlin Native is the LLVM backend for the Kotlin compiler runtime implementation, and so on. It's a bit like, what? Kind of complicated. So I'll try to explain a bit more details what it actually says. So one thing is, what does it mean to be backend for the Kotlin compiler? So this terminology comes from compilers, not web development. So usually when you have source code, for example, this represents a source code in a Kotlin file, right? And then first step for a compiler would be to transform Kotlin file into another file, could be in memory file, which is called intermediate representation. And from this, it goes into Java bytecode. So this is compiler front end, this is compiler back end. This is just compiler terminology, right? So for Kotlin, in this particular example, this is JVM backend. Kotlin also has JavaScript backend, basically can compile code into JavaScript. And there is Kotlin Native backend, which compiles into standalone platform-specific binaries, right? So as you can see from this diagram, it is possible to write Kotlin source code file, which can be compiled to all of these platforms. It is also possible to write Kotlin code, which can only be compiled to one of the platforms. And what I will be talking about is just Kotlin native path, nothing else. And if you want to compile to all platforms, that Kotlin multi-platform, you can look it up later. And to clarify, in this diagram, when we go from intermediate representation to binaries, this is Kotlin Native backend, but the whole thing is called Kotlin Native. So if you're using Kotlin Native, you don't need to know about intermediate representation or anything, right? So that was about Kotlin backend for compiler backend. Then LLVM. So in case people are not familiar, this is LLVM logo, and that's the LLVM, which looks like an acronym, but it's not. It says VM, but it's not a virtual machine. And this is the website for LLVM. As you can guess from the amount of CSS, this is not a JavaScript framework. And in fact, it's a tool set for creating compilers. And even if you don't know about it, it's actually quite big and quite a big thing. So, for example, all these technologies are basically powered by LLVM. So starting with Clang, Objective-C, Rust with Julia, Graal, they're all using LLVM. So if you're using iPhone or MacBook, so the chances are that binaries are compiled underneath using LLVM. So it's a good company, and it's a good technology to reuse. So expand on what I showed before. So there was Kotlin Native backend, right? It goes into binaries. In reality, it's slightly different. It goes from intermediate representation into LLVM intermediate representation. And the last step is done by LLVM itself. So this way, Kotlin Native just reuses all the infrastructure. So it essentially supports all the platforms that LLVM supports. And that was about LLVM. So what does mean runtime implementation? In Kotlin as a language, there is this abstraction level. At compile time, you will have Kotlin.string as a type, right? At runtime, for JVM, it will become Java-lang string. For JavaScript, it will be JavaScript string, and for Kotlin Native, it will be K-string, which is some C++ code, right? And there are other classes in Kotlin package, and at compile time, they all look the same, but after compilation, they become platform specific. So that's what it means to have runtime implementation. So basically, Kotlin Native re-implements all those standard library classes in Kotlin. Also, Kotlin Native has reference counting and native specific code, which we'll see a bit later. And so hopefully this definition makes a bit more sense now. So also there is a question of why would you want Kotlin Native? So there are a couple of reasons. I would say performance, but performance in a broad sense, because not just faster performance multidimensional problem, you can look at this, for example, talk by Martin Thompson. It's really good. It makes an argument for virtual machine, but there is a counter-argument to not use virtual machines. So by performance, I mean in general sense, you can have more predictable behavior. Also, C APIs, because in Java land, I think we live in a golden cage. So there are so many other technologies we could use through C API, like that's at least. And so maybe with Kotlin Native, Kotlin community will be like more open to C APIs. Who knows? And then the Kotlin itself, because it's quite nice and high-level language. So I think, like for example, Rust is more complicated than Kotlin, and just Kotlin itself is a good proposition for native development. And that's the end of the lightning talk. So now moving on to actual live coding. So what I'm going to do is a Snake video game. I hope you know what it's like. Otherwise, you will figure out as we go. Right, and I will use ncurses for UI, which is basically a library which lets you treat your terminal as a canvas and just draw there. So there is a disclaimer. I'm not going to write as many unit tests as I should have written, and I wrote initially just to save some time. And this is a happy path, so when you actually develop a program, it's not like that. So moving on to this thing. So here you see this is a C line, and here's hello world program, so I can open terminal, and for Kotlin Native there is this there is Java C, and this is Conan C, this is Conan compiler. If you know C++, there is Conan package manager, so this Conan and the other Conan, they have nothing to do with each other. It's a bit confusing, but that's what it is. So here you see the program, it says hello from PID, and then it calls function PID. This is string interpolation and so on. So this produces a program kex, so it's a standalone program. You can see it's 700 kilobytes. And if I run it, as you would expect, it just prints PID. Right. I can also run it from ID, and it also prints a PID, different PID every time. So the interesting thing here is that we can open man page, for example, for get PID. This is equivalent to typing it on command line, right? And we can see this function get std, it comes from this header file. So this is like actual C code, right? And it returns some value of PID, so it takes nothing, void, this is C code, right? So let's just extract a variable and call it PID, can specify type. And you can see this type in Kotlin matches what we see in C. And I can even navigate through here and see what it is if I jump view. This is just Kotlin int. And there is a similar thing with get PID. I can jump into definition, and if I navigate later on into project view, you can see this bunch of libraries here, and they're all connected to the project as external libraries, pretty much. So you can see there is a bunch of frameworks for OS X, and there is POSIX, and so on. So the reason I can see this function is because it imports comes from POSIX. So what is happening is that Kotlin Native, there are binaries for Kotlin Native for different platforms, for Linux, Mac OS, and so on. So they know that POSIX is available out of the box on OS X, though Kotlin Native comes with pre-generated bindings. So that's why I can just use it without doing anything. But you can generate similar bindings yourself. And the way it's set up, it's a bit obsolete, what I'm showing. But basically, it's just some Gradle file, and then you say this is a source code, and there is test, and so on. So there is no magic or something like that. So let's move on to something, to an actual snake. So I guess let's have a data class called snake, and it will have some cells. So it will be a list of cell. And data class is a bit like a sealed class in Scala, it's like value type, pretty much. And then cell will have two coordinates of type int, x and y. And snake will have a direction. And it will have type direction. And direction will be up, down, left, and right. So we want to create snake here, and it will have a bunch of cells. So let's say it'll be list of cell, and let's have cells. The first cell by convention will be snake's head, and the rest will be like snake tail, and this snake like looks right, pretty much, right? So its direction is right. And let's say extract a variable. So what we want snake is to kind of move something like that, right? So let's write an assertion, assert equals, and after snake moves. So it will be kind of functional interface where snake is not mutable every time we create a new instance. So we create a member function here, and just for now, let's return this and just see what happens. So like to see a failing test. So another thing here is that you can see Kotlin.test assert equals. This is an example of this platform functions. Platform functions, so they are defined differently for each platform. So for example, for Java, it will become JUnit. For JavaScript, it will be some other framework, and here it's implemented from scratch. So I forgot to update cells. So if we move right, we need to move cells by 1 by X direction. So as you can see now, if I run this assertion fails, and you can see that, for example, it says expected snake with cells 3, 2, 1, but it was 2, 1. So you can see that snake and cells, they have two string methods. They were auto-generated because data classes. Right? And you can see stack trace here. So you can see it's coming from native code as well, so it's not Java at all. And this is probably the entry point in our program. That's some other stuff, and that's the assertions. So unfortunately, like right now, there is no way to jump back into Kotlin native code, but I think it's coming as a feature. So to implement this thing, we could just do a copy. And let's say we create a copy of the snake with cells, which will be updated. So let's say we have new head and new tail. I'll do it in a bit more complicated way than it's required right now, but it will be useful later. So let's say for new head, we'll create a copy of the head and move it into in the current direction. Otherwise, new tail will be all the cells, but drop in the last cell. So what we're doing here, basically creating a copy of the head and dropping the last cell. Instead of moving all the cells, we're doing it this way because it's useful. So here I can, for moving a cell in a direction, it pretty much will be X of the cell plus direction shift in by Y coordinate. So, and similar to Java, here we can define values for enum. So the dx and dy. And coordinates, just in case I didn't mention, they go in like this. So for Y, for up, it will be no shift horizontally -1. For down, it will be this. And for left, it will be -1, 0, and for right, it will be 1, 0. So now if I run this, it should not show any stack trace. So just to repeat this, the idea, we take the first cell, create a copy by moving into current direction, and then we drop the last cell and concatenate these things into new cells. So you can see now nothing is failing, but obviously it's not the right place to write assertions, so let's move into tests. And maybe create class called snake tests. And there will be a test, snake moves right. So I just copied this code pretty much into a test. And I can run it from here. As you can see also in Kotlin, you can use backticks and in native to have spaces in test names, which is kind of nice. But otherwise, it's the same code. You can also see there is this annotation, which is test, Kotlin test. Again, this is example of something. This test is defined inside standard library of Kotlin, and then it's available on different platforms. And so you can see the test now passed. The interesting thing here is that if I switch to here, this test doesn't run in Java or somewhere like this. It's actually an executable file, so I can run it like this from command line and can see output. So what you can see is ID is running actual executable and just presents this result in a with nicer UI. So and this is kind of fine. So maybe it's a good time to try and do an actual graphics with end cursors. So all end cursors, I'll type some functions without explaining them too much. But basically end cursors, the first function you need to call init screen. And you can see if I open man page, again, it comes from end cursors header. And it says it's normally the first routine to call to initialize. It basically moves terminal into a different state where we can use it as a canvas. And at the end, we need to do end win to go back to normal mode. And we won't probably have game size like this, 20 by 10. And let's create new window, which will be height, width, and this original coordinates. So we can see from main page its number of lines, columns, y and x, and then it returns, interestingly, a pointer to a window, so let's call it window. And at the end, we need to remember to delete this window. It's like deallocate memory. And the main point for having this window is actually to be able to draw a box around it. So let's do it this way. And after we draw the box, we need to do refresh on the screen and basically make sure it's painted. And also, we might print something on the screen. So for example, inside the window, let's do in third line, second column, let's print something like this. And this will be a representation of the snake. So this will be kind of snake's head and its tongue. It's like pseudographics. And then after all of this, we need to maybe read a couple characters. Otherwise, all of this will happen really quickly. And you will not be able to see what's printed on the screen, because this end win will actually clear the terminal. And so now I'm running it from ID, and as you should see in a second, it's not going to work. And the problem here is that inside CLine or IntelliJ, just the terminal is not the right terminal for this type of thing. So what we need is actually run it from normal terminal. So I'll do it like this. So now we can see that's what it be printed pretty much. If I press 1 now, so I pressed Q. If I press Q or 1 for let's do here. Let's do if I press 1 here. You can see it prints out, so that's probably not something we want for the game. So let's do, there is a function called no echo, so it will stop printing things. And there is a blinking cursor. We can also get rid of it by doing cursor set to 0. So that's kind of the game for now. And there are a few things going on here. So it might be useful to look at it an example on this function, which prints to the screen. So again, I'm looking at man page for this function, and here is the signature for over here. So the first argument here takes a pointer to a window, so we can specify type explicitly. And as you can see, I'll make it not nullable here, but as you can see in Kotlin Native, it can represent pointers in C with its own class. And I'll come to this a bit later. So the next two things we can see in the C code is that it takes an int. And as you can guess, this is a different int. What we're using here is kotlin.int. So it's not necessarily cint, but in this case it is. So kotlin int becomes normal cint. And then in the last argument, we're taking a const pointer to chars, right? And as you might suspect, this is not just a char array, because I can do things like to lowercase here. So it's inspired by Java API, but this is not Java at all. And so the way it works in Kotlin Native, it's a bit similar to Java. So string in Kotlin Native is defined in two places. So one of them is string KT, so it's partially defined in Kotlin. And here, that's the actual source code for this file. And similar to Java, in Java you can have native methods. In Kotlin they're called external, and so it says basically it's implemented elsewhere in C code, C++. And this is the name. So I also have source code for C++, so I can open C++ code, search for this string. Should be somewhere. Yeah, that's the actual C++ code, right? So these two classes, they basically become kstring after compilation. So this doesn't match the signature. And the whole point here is that this class doesn't match the signature. And what's happening? There is one more thing: is that there is a bridge code which Kotlin Native generates. So if I click through this function from ID, it actually doesn't show it, but I have it over here. And the main point here, it's a bit like lots of details, but you can ignore this is third argument we were looking at. And then you can see here, when we actually pass it to something, we extract C string, get a pointer within some memory scope, and so on. But the whole point here is that Kotlin Native does some extra steps to make these calls easier. And I guess the selling point for it is that similar to Kotlin integration with Java, which is like quite good, it's the same idea to have really good integration with C, so that you don't need to push too much effort. For example, similar code in Scala Native, you would have to do some manual conversion from Scala string into C, and so on. So this is kind of fun. Also, the other thing which I did mention, so this code, like ncurses, it comes again from pre-generated packages for Kotlin Native. The reason it's happening because and curses, it's coming bundled always with OS X. But for example, it's not bundled with Linux. So if you do the same thing on Linux, you will have to generate it yourself. So you can do it in a way, something like this. So you can specify a few more things in your Gradle file and point to this file with definitions, right? And in this file, you can have, this is the header file with C code and how you do linking and so on. So I'm not going to do it here because it's already bundled, but basically I'm trying to say you can just easily generate all these bindings yourself. And so that's like explaining roughly what's going on here with all these things. So just in terms of the game, maybe we should have something like input to be able to read input. I'll create as an int, and while input converted to character not equals to Q, which is for quit. We can do pretty much all of these things. Also, we need to do it clear because it's going to be in a loop. We need to kind of clear the window. And then we don't need to do it twice. So we can just do input equals that. And then we probably want something like snake.move. And I'll copy snake from the test. So let's define it here. Import this thing and make snake into variable. And we kind of also want to for snake to actually move, let's do a very simple thing for now, just define just its head in X direction. So current snake moves right, so if we do it, we should see it moving right. So I'll define head, which will be just cells.first. And I can refactor it here because it's also head. So just to repeat what's going on here, so we have input variable, we're comparing it to Q. If it's Q, we drop out of this loop and just finish the program. Otherwise, we clear the window, drop box, print snake, but now we put in the right X position, right? And then it's still not a real snake. And then we just read character and move the snake. So let's try it from command line. So now, whenever I type something, snake kind of moves. It kind of becomes weird at the end, but we'll fix it in a second. And if I press Q, it exits. So to fix, it wraps at the end, and we should probably fix this. So to do this, let's rewrite it in a bit more, in a proper way. So this let function basically takes a lambda. So this is not a special syntax. This is just a lambda like this. And then inside the lambda, it means the head. So I can do it y and it x. And the head should look like this, right? So that's the actual position of the head. And also we might have a tail. And for tail, I'll do for each loop. And it should, the tail looks like O. So let's create tail. And tail will be, again, just quite simple, just drop in the first cell pretty much. And also there was this weird thing I had to type whenever a snake moves. What we can do, we can use this function called HalfDelay. What it does is when this is a blocking function, but with HalfDelay it will wait for 200 milliseconds, that means 200. And if I did nothing, this input becomes 0. So if I don't type, snake should move by itself pretty much. So if I do it now, so you can see I don't type, but it keeps moving. And it's also like size of 3, which is correct. The only weird thing is it appears at the top where the border is, so that's not correct. And the reason is that our width and height, they defined for the whole window, so we probably want window. So it depends on what we mean by width and height, but let's mean it will be the game area, not the actual window. So just I'll do here +2, because there is left and right border, so we want window to be a bit bigger. And also all of these coordinates, they should be +1, because they're shifted. So yeah, so this is kind of good. Maybe the last thing to make it actually playable to some extent is to make sure the snake can move, change its direction. So I'll do a quick test here, which will be snake changes direction. And I guess what we want, something like function on the snake which says turn in direction down, right? And then it moves. So turning down means its direction will become down, and instead of cell 3, it will move by y +1, so down. There is, though, an interesting kind of edge case. So what if the snake, it moves right, right? It's a mutable snake, so it like moves right, and then we turn left, we tell it to turn left. And there are a few solutions to it, but like in this implementation, I'll just say, let's ignore it. And if the opposite direction to the current, it just will do nothing, right? So let's create member function. It will be new direction. And here we can say, if direction is opposite to new direction, then we do nothing, return the current snake, right? Otherwise, we just create a new copy with direction, which is new direction. And is opposite also not as complicated as it might sound. Let's delete this, and it'll be just that. We'll say if dx plus that dx equal to 0, 0, and dy plus that dy equal to 0, then it's in opposite direction. So as you can see, up and down are opposite. If we add up -1 and 1, it's going to be 0, so that's why it's going to work. So currently, what we're doing here is basically changing direction and then keep moving and checking that the coordinate changed in the right way. So both tests pass, this is good. And what we actually want is, in our main loop, we want to probably change direction here before we do it turn. So we say turn in direction, right? And then direction will be here, and we can do pretty much a switch statement on input converted to character. So I'll use IJKL for navigation, so there's like up, left, down, right. And you can use arrows, it's just a bit more effort and cursor, so I'll just do the easy thing. So this will be direction up. This will be left. This will be down. And right. And we also need an else statement because Kotlin wants this expression to be exhaustive. I'll just do null. It's not necessarily the best solution, but it will just work for now. So say direction can be null, and Kotlin is quite strict about it, so we need to check for null. Basically, if it's null, we'll do nothing. Right? So that's the whole code. So we read the character, switch in the direction, and then based on this shortcut, we change snake's direction and just keep moving in there. So now, as you can see, I can actually navigate around, although it like goes out of the border, and probably an actual snake game you want to die at this point. But other than that, it's kind of almost functional. So it's also, snake is quite small. Let's make it a bit longer, just for fun. And there is quite a big thing which I kind of glossed over, but it's really essential for native development, which is memory management. And so far I didn't mention anything. And in a way, it's kind of, this is a selling point for Kotlin Native. You can get quite far without even thinking about this. And so the thing what's going on, so for example, our snake, it's a mutable object, and every time we move, we pretty much create a copy. So what's going on is that Kotlin Native, it does reference counting. So for all Kotlin Native objects, it will do automatically memory management for you using reference counting. I think the plans are that in the future it will be a pluggable mechanism which is more specific for a particular platform. You could have some simple GC, for example, and so on. And for obviously you cannot do easily reference counting for objects which you don't own. For example, this new window basically function, it allocates some memory on heap inside C, and then we get a pointer back, right? So this is why we need to manually do delete window, basically do memory management ourselves. And there are ways to do it in a C-style way. So for example, there is a global object called native heap, and it can do just allocation. So I'll type some code here, and I'll delete it later. So for example, we can allocate time spec, and I click through on time spec. It's pretty much a C struct, right? So we allocated something in memory, and then we can get time spec back as it will be time spec, but basically we allocated it, right? And then at the end, we need to remember to delete it. So it's like old school memory management. So if we can also do it twice, and it will be an error. We can also do another time spec and forget to allocate it. In our case, we could actually do something like this, like window and raw value, and this will deallocate the window object. We shouldn't really do it because del win is a better way to do it. So this is like the dangerous way. There is another way, which is using arena objects. So let's say we have arena, and then in arena we can allocate, again, time spec, let's say. And then we allocate it a few times, but then at the end we do arena clear, and all the objects allocated here, they will be deallocated. So we don't need to pass around reference to time spec. We can just use one reference for the whole arena. So it's kind of scoped by this object. All the allocation is scoped by this object. And the third option, which is like the best option, is to use memscoped function. So it's a function which takes a lambda, and there inside the lambda we can call allocate, and for example allocate objects, right? And at the end of the lambda they will be automatically deallocated. And the benefit obviously is that you won't forget. If you throw an exception, it will be all done for you. So that's the best and safest way. There is also like a small twist to it, which is that arena can have this function defer, which is pretty much like deconstructor thing. And also memscoped can also have defer callback, which you register, and this happens before deallocating objects. So actually, because memscoped and defer is probably what we want, because we don't want to do free on this pointer. So we want to just remember to call the right function at the end. So let's put memscoped around the whole main function. Just do it like this, right? And I'll make it unit. So now we can do, for example, after initializing the screen, we can say defer, and just copy this end win function and put it into defer. So this way, as soon as we switched into this end cursors mode, we remember to register a callback to clean up after ourselves. And the same with deleting window. As soon as we allocated window, we can do defer and just delete the window like this. And as you can guess, this defer also will run in the reverse order. So this defer will happen first, and this will happen second. So, and it should all work the same. Yeah, so I'm recompiling, but in reality, it will work the same way. So yeah, that's like a quick intro to memory management. And now to kind of move on with the game, let's maybe do a bit of refactoring and just extract a game class. It will have also be a data class which will have width and height, and it will have snake in it. And we can define it here. Let's say game, it will have width, height, and snake. So it's like a replacement. We're basically wrapping all the objects that we have. And then we have game. So now that we moved ownership of those variables, we should just use game everywhere, and here instead of snake as well. And at the end here, we probably want something like game update and direction. And I'll just create this function, but it will be very straightforward again. So what we're doing, we're creating a copy of the game, and the same with the snake. So all we've done is basically wrapped all these objects with height and snake into game. So I can make it immutable. Snake is used once, I can inline it. Same with height, width. And let's put arguments separate lines, add names to them so it looks a bit nicer. Right. And then we can do small refactoring. Maybe here, all of these things, they're related to drawing on Windows. So let's go function called draw. And you can see the function takes a window and a game. Could do this, for example, convert parameter to receiver. So now instead of window, we can say this and pretend this function exists on this type. It just looks a bit nicer here. Window, draw game, and game doesn't need to know how it's drawn. Right. And now let's add a bit more like new functionality. So let's say if game is over, then we want to print things. So let's say print on the first line with this shift, we'll say game over. And in the second line, we'll do your score is, and some score. So it's like game.score. And let's implement these as members. So score, well, we can do it really simply by counting amount of cells, because the snake will be eating items like apples, right? And if it grows really big, it will be hard to avoid collisions. So that's why we count it as a score. And then game is over is also kind of simple, because there are two conditions. One is when snake bytes itself, so it basically means tail contains snake head. That's game over. Otherwise, the condition is that snake cells are outside of the border of the game, so we can say snake cell it any cell, it's x, not in the range between 0 and its width. So something like that. And the same with y, but with height. So this should kind of work. Also, like one small thing is that if game is over, we should stop updating the game and just return the current game, pretty much. So that's the whole idea. So what we did a bit of refactoring, then extracted this function where we added game is over function, right? And then we did is over and score over here. So hopefully this should be straightforward. So now if I move left, game is over, and score is the length of the snake. If I move right, also is over. These are great examples for unit tests, really. And I bite myself quickly. Yeah, worked. And go up, also works. So the last feature is actually to maybe have some apples for the snake to eat. So let's create a class apples. Also I'll do it in an incremental way, so we can just edit width, height, and we'll have cells. And it will be a set of cells. And initially it will be an empty set. Yep. And it will have some growth speed, which I'll explain in a second, but let's say it will be 3. Right, and there will be random. This is useful for testing, but right now it's kind of irrelevant. So now we have apples, which are not used anywhere, so we can plug them into here and just create. So apples, it's a bit like an appled field, would be a better name probably, and it will have the same width and height as the whole game. And when we update the game, we want to update, I guess, apples and just say apples.grow, right, so that there are additional apples appearing. So what it means for apple to grow, so let's say if random next int of 10 is greater than equals to growth speed, then we will do nothing, just return the original one. So what it means is, it's this is roughly 30% of anything growing on the field. So if we do out 10, so that's the idea. Otherwise, we'll create again a copy and we'll create cells plus I want a new cell, right? So it's like next int width and random next int height. And the last thing is to actually draw apples. So we'll do it in the draw function. So I have apples, cells, and we just draw them as dots. It would be nice to use some emojis, but unfortunately it depends on ncurses binary, so it is possible to do it, but it's just more effort, and if you want, you can try. It's all because of the width of characters in terminals. So now hopefully we should see. We also print apples before snake so that they appear kind of under the snake, right? So now we can see they appear at random locations. And the last thing is actually to make snake eat them, because otherwise it's not playable. And we can do it in the game update thing. So where we do snake turn, let's extract it into a variable called new snake and do a bit of formatting like this. So we do turn snake in direction, move it, and at the end we can say eat. And what we want to eat, probably apples.grow. So we kind of grow apples and then eat them. But then this will modify apples themselves because they're immutable. So we should probably return like a tuple. So it's called pair in Kotlin. And we can return new apples here. So that's the whole idea. And let's create is as a member function. So it will return a pair of snake and apples. And this should be apples. And the first thing, if apples, so the first condition, when snake doesn't eat any apples, right? And we say snake cells don't contain, apple cells don't contain snake's head, then we just return everything as it was. So this is the same snake and the same apples, not modified. Otherwise, we need to create a new pair, and this will be a copy of the snake. And we'll keep track of eaten apples as a counter. Let's say eaten apples +1. I'll create this in a second. And apples, we need to remove the apple which has been eaten. So we'll say cells and apples cells minus head. So just like kind of remove thing. Yeah, and let's create eaten apples here. Put parameters in separate lines. Eaten apples will be of type int and 0. And so now all we're doing, we're just incrementing this value, but not actually growing the snake. And with a convenient place might be here. So we say if eaten apples is 0, we will create new tail by dropping one thing at the end. Otherwise, we'll just return cells. And this way, the snake will grow. And obviously, we need to kind of, on each step, we'll reduce the amount of eaten apples. But then we don't want to go into negative, so let's just do max off. This is kind of a quick way to do this. To be fair, with this implementation, it doesn't even have to be an int, it could be a boolean, but kind of looks nicer. Maybe you could have special apples, which grow snake drastically. And so this should be pretty much it in terms of the game. So let's try it again. So now it is growing, I think. And I'll try and keep playing it for as long as I can, but no guarantees. I wonder what is a good strategy for this. Okay. So just to look at the size, so it's like 1.3 megabytes for this executable. It's also, if you run Valgrind as like a profiler for native apps, you can see this is how much memory it uses. We shouldn't really look at it because Kotlin Native never been optimized as far as I know. So basically, horizontal line is time, vertical line is heap usage, and you can see it fluctuates around 1 megabyte pretty much. It's like hard to do with actual Java, right? And it's despite of us not trying to optimize anything, so this is the actual program, right? And what I showed is kind of was, I guess it looks a bit silly, but you can actually, this is the same program, but slightly better UI and using SDL graphics library, right? And this whole thing, if I open source code, it's pretty much what we've seen. Okay. So we've seen like all games, snake and apples, they are like the same classes. So what I showed maybe looks a bit like a toy example, but in reality you can write something better. Obviously UI here is more complicated than what I showed, but anyway, so it kind of can take you somewhere, this implementation. Right, and so there are more things related to Kotlin Native. What I showed is like tiny intro into it. So there are things like two-way interop with C and Objective-C. So not only you can call C, you can make C call Kotlin Native. There is also a concurrency model, which like with workers, which is not a classic mutable shared state in C. You can also freeze objects to prevent them from being modified. You can pin them and so on. So there are more things, you can look them up. But also you get all the native stuff, like true memory leaks, segmentation fault when your program crashes, all the good things. And some takeaways, so if there was some continuum between like C and Kotlin, right? Like Kotlin, I mean Java Kotlin, right? So then Kotlin Native goes somewhere here. So it's not as easy to program as maybe JVM, but if you know Kotlin, like let's say, if you know Java, you almost know Scala. If you know Scala, you definitely know Kotlin, and if you know Kotlin, you know Kotlin Native, so you can definitely like easily write native code, right? And compared to Rust or Scala Native, they're probably a bit not as nice as Kotlin, I would say. And if you're interested, I also re-implemented the same game in all these technologies, like Rust, Scala, Go, and Graal VM. So if you want to compare what is the difference, you might also want to try Graal, it's quite interesting. So if you want to check one out. And also, I have to mention, this is early days for Kotlin Native, so you know it's not released, so you shouldn't expect everything to be perfect, right? So a few things, for example, slow compilation, and as far as I understand, it's not some single bottleneck. It's basically the whole infrastructure, including LVM. So Kotlin Native team, they're aware of it, they will work on it, but not maybe right now. Also, ID support is not ideal. I used quite an old version of CLine because I got everything working over there. And other tools are also not perfect. So what can you do next if you want to try it out? So I would recommend just going to GitHub. There is Kotlin Native project, and there are examples. So there is a folder with samples. You can look and compile them locally and basically play with them. Then there are quite a few of READMEs. Obviously, you can go to kotlinlang.org, but I think these are more likely to be up to date, or you definitely will see the latest information over here. So there are well-written READMEs in GitHub repo. And you can also go to kotlinlang.org, you read references, tutorials, and so on. So that's a good start. And there is also a channel on Kotlin Slack. And because it's early days for Kotlin Native, you have this luxury of people who are actually working on it right now. They will very likely answer your question. So it was like this for JVM Kotlin a few years ago, when you could get actual developers, creators of the language, answering your question. But now Kotlin grew so much, you don't get this anymore. But for Kotlin Native, you still get it. So it's cool. And Kotlin Native looks like a very interesting project. I hope it goes well in the future and will be a strong competitor for other languages. So good luck to Kotlin Native. And if you like this, I'm trying to record some YouTube videos, you can look at other things that I've done. And this was live coding Kotlin Native Snake. Thank you for watching.